Let me ask you this. What do you do when the weather gets unbearably hot? For most of us, we'd probably grab a nice cold drink, maybe crank up the AC. But for the Rohingyan people residing in the Kutupalong and Nayapara refugee camps of Cox's Bazar, these are luxuries that simply cannot be afforded. Every year, Cox's Bazar Sadar Hospital is forced to admit over 500 patients daily due to the unforgiving dry season, despite a 250 bed capacity. Overwhelmed by severe cases of heat stroke and viral fever, over 1,000 of these patients are treated outside under the harsh Bengal sun. Forced to flee Myanmar to escape genocide, over 1 million Rohingyans have settled in Cox's Bazar under the shelter of makeshift bamboo and tarpaulin housing. In what is described as the most urgent refugee crisis in the world by the UN, the Rohingyan refugees are subjected to inhumane living conditions amidst mounds of waste, rampant diseases, and sweltering temperatures. We believe that the battle against the scorching climate of Cox's Bazar is one that the Rohingyan people should not have to face unprepared.
So, what tangible actions can the Rohingyan refugees take to mitigate extreme heat exposure?
Introducing Solarguard. Solarguard is a reflective roofing system that leverages upcycled waste, natural materials, and local capabilities throughout Cox's Bazar to mitigate extreme heat exposure. Designed to integrate into the roofing configuration seen across the refugee camps, Solarguard is made from a layer of aluminum metallized film integrated between the woven bamboo roofs and tarpaulin used in these camps. The aluminum is sourced from the World Food Programme's food supplies waste, which sees the collection and processing of the abundant packaging encountered throughout the refugee camps. So how does Solarguard work? Solarguard was designed using the thermodynamics concept albedo, a non-dimensional scalar ranging between 0 and 1 that denotes the proportion of incident light reflected by a surface, or solar radiation in our case. Based on empirical studies, aluminum foil typically exhibits an albedo of 0.76, whilst blue tarpaulin, which is often used as an exterior shell in the refugee camps, has an albedo of 0.15. From these values, we use Brett et al.'s equilibrium surface temperature equation to estimate that our Solarguard system could have the potential to reduce roof surface temperatures by upwards of 8 degrees Celsius, assuming all else constant. We also calculated the roofing coverage in both the Kutupalong and Nayapara refugee camps and scaled the implementation of Solarguard from one household to each entire camp. With 100% Solarguard implementation, we estimate average ambient temperature reductions of 3.34 degrees Celsius and 1.06 degrees Celsius for the Kutupalong and Nayapara camps respectively.
Alright, Jimmy, enough of all this theory. Let's put our system to the test and see if it actually works. After thoroughly warming up, we set about constructing two scale model shelters, one with our Solarguard system and the other without. We did so by building timber frames, installing tarpaulin sheets, and weaving bamboo facades to simulate the refugee shelters. After ensuring that internal temperatures were equal at 23 degrees Celsius, we placed both models outside under direct sunlight with an ambient temperature of 27 degrees for a 40-minute period, recording the internal temperatures in 5-minute intervals. The resulting graphs reveal that the Solarguard model produced lower internal temperatures over time, reflecting the trend closely aligned with our theoretical estimations. A maximum temperature difference of 4 degrees Celsius was recorded at the 35-minute mark, with the thermal advantages of Solarguard illustrated on the right. During the early design stages of Solarguard, we placed the sphere standards and the United Nations SDGs at the heart of our design approach, with a direct focus on Goal 3 by reducing exposure to dangerous levels of heat in the Rohingyan refugee camps. We also directly addressed Goal 10 and the thermal comfort guidance in the sphere standards by improving the quality of life at home for vulnerable groups such as women, older people, and the disabled, who spend considerably more time in these shelters. Finally, Solarguard directly contributes towards Goal 8 through its supply chain, which provides opportunities for community members to collect waste packaging, craft Solarguard, and then sell it to those in need to create jobs.
The Solarguard roofing system has been designed to be highly adaptable to cater to the user's evolving needs. Solarguard's layer configurability allows users to alter the design to accommodate different climates and weather conditions, introducing additional waterproofing or bamboo to reduce glare as necessary.
The simplicity of our model means it can scale with minimal resources and can also be employed by other communities such as Nahr al-Bared and Zatari refugee camps in Palestine and Jordan who experience similar issues relating to both waste management and heat exposure.
The humanitarian atrocities faced by the Rohingya peoples are systemic issues that won't be solved overnight. As Team Lumos, we aim to contribute to the betterment of living standards for these refugees and hope to provide stepping stones for lasting improvement.